Okay, in this part of the Bipolar PROM presentation, this is the AR32A programming unit. You have probably, if you've watched any of our other videos, seen it before. But I want to point out something about it which is kind of unique to us that other programmers do not have. And that is this. Let me find my pencil over here. Okay, we have an accessory connector. It's right here. The accessory connector, when our product was designed, we recognized that there were probably going to be parts introduced that we weren't not going to be able to accommodate with just the signals that came out of the socket. All right. So what we did was we decided, rather than to come up with yet another programmer every couple of months or years or whatever, like most of the other companies did, we would just stick with standard memory parts. And one thing that people who work on the vintage and early equipment might be interested in about the AR32A programmer is we actually support the first generation EPROMs, the 2708, which has the requirement of 26 volt programming pulse, positive 12, negative 5. All of those are in the socket. You don't need an adapter to do those. The same is true for the TMS 2716, because at the time when those EPROMs were released to the marketplace, the fabrication technology required 3 external voltages. That's what was necessary in order to make them work. Well, yeah, as time passed, they improved, and the external, the negative 5 and the positive 12 went away. But during the years that it was there, that equipment still needs them if it's going to function properly. So anyway, I just wanted to make the point that that's all built into this programming unit, and this is a pretty robust design. It's not something today you can get, your $50 inexpensive Chinese programmer. That's not what this is. Okay, this is different, and it does a whole lot more than those inexpensive products. I'm not bad-mouthing the inexpensive products. As they say, you can buy better, but you can't pay less. So anyway, what I wanted to point out is that, let me zoom in so you can see the accessory connector. Well, I really zoomed in there. Okay. We have available plus 5 volts at this pin, we have ground at this pin, and we have plus 35 volts at this pin. Okay? And then over here we have 12 volts AC, so that in the event that you needed 12 volts AC to create some voltage which was not available, something negative, you could do it on an adapter, because that's how we address different technology families with adapters. And the last pin is VPP, which is the programming voltage. And now the VPP and other functions that occur at the socket are all selected and controlled by the software that we use to operate the programmer. So anyway, that is how we're able to do bipolar proms. Okay, now let me show you a bipolar prom. Okay, this is a national part. This is a 32K by 8. This is a 74 S188. The corresponding Philips Signetics part is 82S 123. Also, I'll explain something else that I didn't really cover before, and that is there are variants of these bipolar proms which are what are called open collector. Okay, because open collector allows you to connect outputs together where otherwise you wouldn't be able to connect outputs together, because that would be damaging to the component. So the open collector version of the 82S 123 is the 82S23. Both of them work the same way, it's just the outputs that are different. Okay, now, here is another bipolar prom. Which I have got turned around. Okay, this is an 82S 181. This is 1024. I didn't have an 82S 191, so all I have is an 82S 181. And you can see we wrote in pencil on it, test chip, which means that when we were developing the bipolar prom adapter, this is one of the parts that we used for testing. But the thing that I want you to notice is how much bigger it is. Okay, as is in the case with any memory component, the more capacity the part has, the more address lines it's going to need. Okay, so bipolar proms, they existed in three package styles, and or three not package styles, three physical sizes. You had the 16 pin, the 18 pin, the 20 pin, and the 24 pin. Let me get my data book. I can show you that. Okay, this is the page out of my monolithic memories data book. So the part numbers don't reference National or Philips Signetics, but what I wanted you to see is the different sizes. Okay, these three are 16 pin, this one is an 18 pin, and these 18 pin, 18 pin, 18 pin, 20 pin, and then 24 pin. Okay, so those are the sizes of bipolar proms that were available and most common. Okay, so that is that. Now, what is the issue when it comes to programming bipolar proms? Okay, well, the big issue is, in order to program a bipolar prom, you have to apply, as I said, you're blowing fuses inside the part. You're not just applying a byte to the data inlines and then a high voltage for the programming voltage and then a programming pulse. No, that is not what happens when you program a bipolar prom. With a bipolar prom, you have to program each fuse, each individual bit. Okay. Now, once they're programmed, then the information is read out as either 4 bits simultaneously or 8 bits simultaneously, depending upon the configuration of the part and its storage capacity. But programming them was not like that. Okay, and that's why you don't see people supporting bipolar proms today, because not only is the programming a robust and high current activity, but the algorithms were different, meaning that, as I said, AMD did it different than TI, who did it different than National, who did it different than Signetics, etc., etc. Okay, so when we did our design, which was quite a while ago, the two biggest manufacturers were National and Signetics. And I will tell you that some of the MMI parts, if you happen to find these, because you're just not going to call up your DigiKey or Mauser and order bipolar proms, some of the MMI parts would, their algorithm was very close to National. Not all of them, but some of them. So I'll just give you that as a little tidbit of information. Okay, just for your reference, this is a bipolar prom cross-reference list, and you can see this is the Signetics out of the Signetics data book. You can see that Signetics was trying to sell their bipolar proms into the same market as other manufacturers. So here we have, meaning that if you had a, let's just pick one here, all right, here's one, I guess, which will work. Here's a Fairchild 93417 cross references to a Signetics 82S126. Okay, now what that means is if you happen to have a Fairchild 93S, 417, then you could put it into our bipolar prom adapter and read it. You would read it as a 82S126, but it would read okay. All of them will read the same. It's the programming that's different. Our adapter will only program Philips Signetics, National, and perhaps a monolithic memories. Okay. So, and if you look, the other ones are not, they're not as common. They didn't manufacture as many. Okay, let's move on to the bipolar prom adapter. Okay, before I do that, I'm going to show you. I had these packages, same sheet that same page in the data book that I had before. When I was talking about programming, how you have to program the fuses one at a time. Okay, well, the problem with that, and early programmers, programmers that were sold during the time of bipolar prom programming, they were not insignificant pieces of engineering, because you had to provide the proper voltage, the proper current on the proper pin of the bipolar prom. And you can see you've got 4 different sizes of part here. So for a 16-bit part, or 16-pin part, you're going to have the address lines are here, okay, A0 through A4, and then your data lines are over here, Q. Well, they're not in order. Anyway, your data lines are over here. So when you're programming 82S181 or 82S123, I'm sorry, 74S181 or 82S123, you've got to have the right pins hooked to the right place on your electronics in order for the electronics to generate the appropriate logic levels, pulses, at the right time to program one fuse in the part. Okay? So when you've got all of these different package sizes, with all of the different pins and where those pins are located, routing electronically all of those signals, if you're going to have, quote-unquote, a universal programmer, that is a tough job. Okay, that's very expensive. All right, well, we didn't do that. We did it a different way, and it worked extremely well. It's not as convenient as the universal programmer, but it's a lot less expensive. So let me show you what we do, and I'll introduce you to the bipolar prom adapter. Okay, this is the bipolar prom adapter. Our part number is A for adapter, and then BIP for bipolar. And let me just point out a few things about it so that you understand how it works. Okay, first of all, these 2 wires which come with the adapter connect to the accessory connector. Okay, because we can't route hundreds of milliamps to blow fuses through the socket on the programmer, so we bring in plus 35 volts and plus 5 volts, which allows the bipolar prom adapter to operate. And the way the bipolar prom adapter works is that if you look here, there are 2 rows of 24 pins, okay, where I'm pointing with my pointer pencil. The pins on this side, and these are machine sockets, so they're robust and will give you a long service life. The pins on this side, on the left side, are hooked to the drive electronics. Okay, here are the transistors that blow the fuses. Here's some timing over here. Here's some address decoding over here. And those signals are all presented on this row of pins. Okay, the bipolar prom socket, okay, 1 through 24, this is a 24-pin socket, are here. Okay, they're on the right-hand side. So we got pin 1 down through pin 24. All right. In order to configure the bipolar prom adapter for the bipolar prom with which you are working, okay, you have to connect the jumpers to the appropriate pins. All right. Well, how do you know how to do that? Well, we provide a document which shows you how to do that. So let me just bring that up, and you can see it, because we know it's relatively easy, but at the same time, this is how we're able to support, the 4 packages of bipolar proms with one adapter. All right, so let me bring up the page on our computer here, and I'll show you. Okay, this is the bipolar prom jumper block configurations. Okay, and you can see that we have over here 32 KB, but 74S188. That is the simplest one to configure because the jumpers just go straight across. Okay, the programming pulse +5, which in this case you actually don't need to do that one. You can see it doesn't have a connection. So you would just jumper all of the data lines and the address lines and the chip enable line directly across from the drive electronic side of the pins over to the socket side of the pins, and you can do 74S188s, 82S123s, etc. All right. But if you are going to do a 256x4 prom right here, like an 82S129, then it's not as straightforward. Okay, your programming voltage still goes over here. Okay, but let's see, am I giving you the correct? Yes. Okay, but here we have down here, for example, we have A6, pin A6, but it goes up here to this pin. Okay, so you're going to have jumpers which basically assign the appropriate drive electronics pin over to the appropriate bipolar prom pin, and this holds true for all of the different parts. Okay, all of the package sizes and the 82S family and the 74S family. All right, and there are 2 sets. Okay, for the configuration, and here they all are. Okay, here's the biggest one is the 2048x8, and we show you which pins go where. Now, let me show you something else, and that is, let me switch back over to the overhead camera. Anyway, that's how you know how to configure it. There's another page which has the individual pins of the bipolar prom shown, which you may find easier. When we would configure one after somebody purchased it, we would use this illustration to do that. Okay, the bipolar prom adapter, since it supports 2 manufacturers, programming algorithm from 2 manufacturers, Philips Signetics and National, in most cases those algorithms are close enough where the National algorithm will program the Signetics part, even though the parameter settings may be different. By parameter settings, what I mean is the programming voltage and the programming pulse time. Okay, bipolar proms use 2 different programming voltages simultaneously. Okay, you end up with, I'm not going to belabor the technical analysis, but you end up with a pulse inside of a pulse, and that's how they manage to blow the fuse, and you generate that particular pulse at a specific time for a specific period of time. All right, all of those adjustments are here. Okay, this potentiometer here adjusts the pulse width, and these 2 potentiometers adjust the 2 different programming voltages. And on the board itself, okay, is silkscreen the different voltages for the 2 families. All right, and the pulse width for the 2 families. Okay, so you don't have to worry about remembering it. It's silkscreened on the board. And the measurement points for 1 voltage, you can, there are test points that are marked, but you can also use the metal tab of these 2 voltage regulators to set the appropriate voltage if you need to. Okay. The other thing about the design of this adapter, and it's true of the design of all of our products, we know that a lot of people, today you buy something, you can't work on it because it's got some custom part, or it's, it's just impossible to work on. Everything that we have ever designed uses garden variety integrated circuits, transistors, resistors, capacitors. It's all through hole. There's no surface mount stuff. So if you're a DIY person or you're a technician, you have to, electronic troubleshooting skills. You can work on our stuff, because if you buy our product, you will get schematics you'll get a schematic for the bipolar prom adapter, you'll get a schematic for the programming unit, and as I said, if you're technically competent, you're not forced to basically not be able to deal with a malfunction should one occur. So I wanted you to see that. That's the bipolar prom adapter, and then in the next part, we're going to install it into the programming unit, and we're going to begin to work with the bipolar prom software.